Hello guys, welcome back to Cloudy ML. Till now we have gone through Matplotlib. Today we will be talking about SEABORN. So before we proceed further with the coding and all the stuff in SEABORN, let's understand first of all what SEABORN is. So guys, data visualization is the basically art of representing the data in the form of graphs. And SEABORN is a very useful tool for professionals who want to work with data. Basically, in this tutorial, we will be working with SEABORN, which is a Python library. Like pandas, we have seen pandas, NumPy, and Matplotlib. Similarly, SEABORN is also one of the library of the Python. It is an open source library and it is built on the top of Matplotlib. And as we have discussed, it is basically used for data visualization and exploratory data analysis. Also, Seaborn works easily with data frames and the pandas libraries that we do have in Pythons, and that graphs that we will be creating over here can be easily customized. Now, there are too many benefits of using Seaborn for data visualization, and few of them are like graphs make it easier to explain your data to non-technical people. Visualization attraction graphs can be presentation can be used in presentation, and reports much are more appealing to the reader. Now, let's get started with the coding part over here. So, before I start further, I would like you guys to know on which dataset we will be working upon. So, basically, this is the dataset which is named as Titanic. Here we have passenger ID over here. After that, we have whether that person has survived or not. 0 basically means that the person has not survived. 1 means yes, the person has survived. Then we have what was the class of that person. And then we have name of the person. Along with that, we have sex, age, SBISP, then we have Parch. All guys always remember 0 always means no and 1 means yes. Then we have ticket number, we have fare, then we have cabin, and then we have embarked. So this is the data set, and now we will be proceeding with the visualization. So for that I will be opening Anaconda, and with the help of Anaconda I will be going to Jupyter Notebook. I hope all of you have this installed on your system. Now I will click on new and I will click on Python 3 and I will start writing my code. So initially I told you that before writing any code, first of all we need to import all the libraries over here. So I will be importing the library. You can notice that in the Python as well, sorry, in the Matplotlib as well, we have imported the libraries first. You can notice we have imported the libraries. So similarly, we will be importing the libraries over here. You can notice here in each and every this pandas, Seaborn, NumPy, Matplotlib. First of all, we need to import the libraries. So let's import the libraries now. Let's rename it first. Seaborn. And here I will be writing, just a second guys, and here I will be writing import pandas as pd, enter, import numpy as np, enter, import, or let me do one thing, let me copy and paste this only. Control C, Control V. Okay, so guys, one thing, I hope you guys are clear that why I am writing pandas as PD, numpy as numpy, seaborn as sn. This is because writing each time pandas, numpy, and seaborn would be hectic thing. This is the reason we have simply given shortcuts to pandas as PD, numpy as numpy, np, seaborn as sn. And in the matplotlib, basically matplotlib is a very huge library. We don't want each package of that library. This is the reason we have simply imported only pyplot which we will be using. Now the next thing that we will be doing is we will be reading the data that we have over here in the Excel file to our this what we say this Jupyter notebook. So for that, what we will be doing is we will simply write, first of all we will copy the path. So let's go to File Explorer, to my file where my file is located. I will simply copy the path over here where is mm, okay. So here I will simply copy the path, Control C. I will go to Jupyter Notebook again, and here what I will do is I will try reading my data. Let's rename my data as DF and I will try to read it. I will try to read it as pt.read, and as the file is, let me check what the file is. My bad. Let me go to where is downloads. Copy as a path. So I have copied it as a path, and you can notice over here that what is the type of the okay R paste. So you can notice this is a CSV file. So always remember, after read we have to use the file name that we are going to read, and I will write it as shift enter. So my file has been imported to this particular Jupyter notebook. Guys, always remember, to run the code we need to enter shift enter so that our code runs. Now our next task is to read the head, that whether the particular data set has been loaded or not. So I will be writing it as df dot head to see my head, and I will click on shift enter. You can notice all the data that was present over here is coming here as well. So we have uploaded the data. If you want, you can simply have the statics as well of this data. For that you need to write df dot describe shift enter. So you will be getting count, mean, standard mean deviation, then first quartile, second quartiles, third quartile, and maximum as well. So using this describe, you can then get the statistics of this data. Now the next thing that we are going to do is we are going to you're going to plot count plot. So let's plot that. So first understand what count plot is. The count plot is a very helpful while dealing the categorical values. So it is basically used to plot the frequency of the different categories. Okay? The column here, what we will be do is we will try to plot it. Let's count plot. My bad. Cloud plot. Enter. And here I will be writing the code now. So basically SNS dot count plot bracket, in the bracket I will be writing x equals to 6, and then I will be writing in data equals to df, shift enter. Guys, till the time it is star, actually the code is being loaded, and once the number comes, that means the code has been loaded. We have made the seaborn as SN. This is the reason it has showed us error. So I will be writing it as SNS, and then I will be running the code. Here you can simply write on run and the codes will get executed again. Kernel restart and run all. Restart and run all cells. Okay. Again we are getting error, and why is that? Let me check that. Count non interpreted input. Okay. Where is my input? Mm, this is my input, so I'm copying this and I will be pasting the same over here. Control V, shift enter. Great. Now you can notice that we are getting the plot count over here. We can see that the number of males in the particular what say a particular Titanic ship was this number, and for female it is showing like this. So basically whenever we will be counting the plot, we need the column and then we need the data set over here. So whatever sex count will be there, you will be getting under this count plot. So data over here represents the data frame and X here represents the column name. Let me write it over here. Enter hashtag data equals to the data frame on which you are working, data frame, enter. Again x is equals to the name of column, the name of column. Now, from this graph, the basically we are getting the number male passengers and the female passengers, and we can notice that the number of male passenger was very about twice of the number of female, and we can further do the breakup of this bar of this cloud plot in the color palette. So let's do that as well. So we are now going to break up the bars in the count plot based on another categorical value, and the color palette of the plot can also be customized over here. So let's do that. So SNS dot count plot and then I will be writing x equals to x again. X is here the column name, so I am writing x equals to the column name that I want. My bad, let me again write xex, okay, and then I want hue, hue equals to let's see what data we have. Okay, I want to see hue equal to survived, control C. So in the male and female, how many number of the people was there who was able to survive? Then hue equal to survive. After that, we need to write the data. Means from which data frame you want to see the this graph. So basically the name of the data set we have given is DF, and then we have palette, PALETTE equals to, I will be explaining the each term with you just now. Shift enter. Now, there is some error. Let me remove this palette and then try. Okay, why are we not getting how many hue has survived? Survived, not survived. Just a second. So I don't know why it's behaving weird for survived. Let's try to have some different one. B class and see if our code works or not. Control V, shift enter. Great, here it is working. So you can notice for each male and female, we are getting the bifurcation again on the basis of P class. That is what was the number of first class, second class, and third class. Again, first class, second class, and third class. So from here also, we can notice that the number of the people in the third class was more in comparison to the number of person in the first class and second class. So you can infer these things from the particular graph. So here what x means is x basically represents here the column, and here what hue represents is hue basically is the name of the categorical column to split the bars. Enter, and the palette that I was used, basically it was the color palette to be used. So you can simply search on the Google like which color palette you want to use, and then you can work accordingly. After the count plot, the next thing that we will be looking upon is the KDE plot. So let's try to plot that. I will again go to, let's add one column over here. My bad. Let's add a column over here, a hashtag count plot I want over here, and let's make it as heading. Shift enter. Great. Again, I had some. Okay. Shift enter. Now, count plot, we have seen how we can draw count plot. Along with that, we have also seen how we can do the categorical column split in the bars. The next thing that we will be looking upon is KD plot. So before we go and plot the KDE plot, let's understand first what KDE plot is. So let's mark it down, enter. And so basically KDE plot is used for to plot the distribution of continuous data. And stands for kernel density estimate. So KD basically means kernel density density estimate, and it is used to plot and it is used to plot the distribution of continuous data. So now let's draw it and see how exactly KDE plot looks like. So similarly, as we have written sns.kde here, sns.count plot, here we will be writing sns.kde plot. We will open a bracket now. Again, here we'll be using x. That is the x-axis that we want. What we want to put it on the x-axis. And here I am writing age. Let's see. So age, A is capital and GE. So I will copying it over here. And I will simply paste it over here. Age. My bad. Age. And then I will be writing data again. Data, you guys have understood why what data is referring over here. Any new term will be coming, then I will be letting you guys that what that new column what that thing means. I will click on shift enter, and you can notice that we are getting the age density of that, which age category people was more over there. So you can notice the people which were in the age of around 25 were more in that particular ship. Now here you can see we have blue color. Let's try to change the color. So I want the color, let's say I want the color as red. Shift enter, and you can notice that this particular line is coming up over here now in red color. Again, x axis, you have understand that x is the name of the column. Data here stands for the data frame, and the column of the graph and the color of the graph is represented by the color. And here the peak of the above graph is in between 20 and 40. So we can conclude that the most passengers were between the ages of 20 and 40. Great. So now let's try to plot a distribution plot. So distribution plot is similar to the KDE plot. It is also used to plot the distribution of continuous data. So there might be some difference, but because KDE and distribution, as we have given two names, so there might be some difference. So let's understand what the difference is between distribution plot and KDE plot with drawing it. So let's name it as distribution plot, and let me mark it down. Enter. So it is similar to KDE plot. Similar to KDE plot. Okay. And it is also used to plot the continuous data. And now let's draw it again. Here, as we have used SNS KDE plot, SNS count plot, here we will be using SNS dot dist plot. So let's write it as dist plot. I will open a bracket, I will write x, and I will be writing x equals to age, and here I will be writing KDE equals to true. Uh, Great. And here I will be writing beans equal to, let's say, 4. And data, don't worry guys, I will be explaining you what is beans over here and why I have written KDE equal to 2. What happened? This plot got an exact keyword data equal to df. Just a second. I guess here I have written, okay, I have to write this plot, not dist plot. Shift enter. Great. So now you can notice that I am getting the graph over here wherein we have bars as well as this line over here. You can notice here we only had line, but here we are getting this as well. Here we were getting density, but here we are getting count. So although these graph is representing continuous data, but here we are getting count, but here we are getting the density. We can notice that between the 200 between the age of 20 and 30, we have around the count of 250 persons over here. Now, what is KDE? So if it is set false by default, so let's try to not write KD this time, and let's write this thing only, and let's see what happens. Shift enter, and you can notice that this KDE line that we were getting earlier by making it true, we are not getting that. So basically it is set fault by default. However, if you wish to plot a KDE graph on the top of bars, you can set it true. So let me write it that what is KDE. So KDE is basically set false by default. Set false. I hope till now everything is clear to you. All the graphs that we have created is clear. Is set fault by default. However, however, if you wish to plot KDE graph on the top of bars, you can make it true. You can make it true. Great. Now, what is beans? So basically the number of beans or bar. The lower the number you will write, the wider the bars and wider the intervals you will be getting over here. So let's try to make changes to beans and let's see what happens over here. So let's make it 1, shift enter. So you can notice this time you are getting a very big beans. So now let's make it 2, shift enter. You are getting 2 beans over here. So whatever the count you will be putting it on, you will be getting the same number of beans. If I want, I can make it 5. So I will be have 5 columns over here. If I will write 6, so I will be having 6 numbers of bins over here. So I hope the concept of bin is also clear. So this graph, the number of columns that we want is represented by beans. So by beans, or if you want that I don't want to write beans, so let's remove that and see what happens. Shift enter. You can notice it has automatically taken any number and is showing the beans as per that. So make sure that you are writing beans over here in order to make your graph look nicer. So the number of bars is denoted by beans over here. So I hope distribution plot is also clear to you guys. So the plot here tells us that the most of the people on the Titanic board were in the mid 20s, like between the age of 20 and 30. Now let's go and see if we can what we can do over here. Okay, now let's see if we can put hue or not. The same thing that we have done over here, we have put the labels of P class. Let's see whether we can do that here or not. So for that, again, let's copy this one. I am copying the first code. I don't want to write the same thing again and again. This is the reason I am simply copy and pasting this one. So we have x equal to age, kd we have make true, means we have 5, data we have already put it as df. Now I want to write hue. So what hue I want to write? Hue equals to, basically hue I want is of df, and I want to see the number of person who have survived. Shift enter. Great. So you can see we are getting hue also now. For example, we are getting the count of the number of person who have survived along with the KDE. If we will be removing this KDE, then we will simply getting this graph over here, and it is showing that this is the count of people which have survived and this is the count of people not survived and this is the count of people which has survived. Let's make KDE true. It was looking more nice. Shift enter. Oh my bad. Comma, shift enter. What happened? TRUE, comma, shift enter. Great. So you can also pass hue a palette parameter over here to customize your graph. And you can notice that most of the surviving passengers were in their high 20s. You can notice this is the number of persons who have survived, and this is the person who have died. So we can infer a lot of information from this. You can also try to see what was the class of the people. So till now we have seen count plot, KD plot, distribution plot. Now let's talk about scatter plot. So scatter plot we have already seen in our previous class that what exactly scatter plot is. So for this plot and the plots we will be working now, we will be working with the data set. That's the same data set. Now, just a second. Now, till now we have seen KD plot, distribution plot, and count plot over here. Now let's try to import a different data set and work the rest of the graphs on that. So let's rename it as df1 equals to pd, that is pandas dot read underscore csv. And before we proceed further, let's see on which dataset we will be working upon. So basically, this is an arrays data where we have ID, septal length, sepal width, width length, width, petal width, and as well as we have species of each and every this particular ID. Now, let's try to first read that file over here. R, and I will be copying the path over here. I have already copied that path and I have pasted it over here. Now shift enter. Again, if you want, you can do the same thing like looking for the head and opening that. It totally depends upon you if you want to open it or not. Now we have loaded the data set. Now the next thing we are going to see is scatter plot. So let's try to plot the scatter plot. I hope you guys are aware that what scatter plot exactly is. And if you are not, so basically what happened? So basically scatter plot is used to represent two numerical data at the same time. And you will get to know it about it once we will be plotting the graph. Shift enter. You can see we are getting the head. Now let's make scatter plot. Scatter plot. So what scatter plot does is it helps understand correlation between the two data. It helps in understanding the correlation between two data. Again, I will make it as markdown. Shift enter. And now I will be plotting that graph. So similarly, I will be writing SNS dot, as we are going to make scatter plot. So I will be writing scatter plot over here, scatter plot. And now I will be writing x-axis, x equals to, let's say I want to have sepal length centimeter over here, and then I want y-axis as well, as I told you that it is help us understanding the data between the understanding the relation between the two data. So I want to have petal length as well. So let's write it as well. Oh my bad. And then I want to have data. We always need to specify the data. So let's write data equals to df, shift enter. It's working right now. Okay, I guess I have missed one thing, that is hue. And let's say hue equal to species. Shift enter. What is the spelling of species? Control C, Control V, shift enter. Scatter plot, x-axis, y-axis. df hue, all thing I have. Oh, my bad. Here basically I have written df. I need to write df1 because our data is df1. And now you can notice that we are getting a scatter plot wherein you can see for each species. Let's remove this hue first. Shift enter. You can notice that you are getting for sepal length, for which sepal length, what is the petal length for each sepal length. So here basically you are getting the correlation between the two data sets. So a scatter plot basically requires data for its x-axis as well and y-axis as well. We can also pass a hue as a parameter to color the dots based on the categorical column over here. So let's pass hue now. Control C, Control V, and here I want to have hue as well. So in the hue I want to see species. In the hue I want to see species. Shift enter, and you can get this. So in this plot above we can observe that an iris flower length, where the length is less than 6 centimeter, and the petal is less greater than 2 centimeter, is most likely the type of this setosa. You can notice all this category is falling under setosa. For the length less than 6, sorry, for the sepal length less than 6, and for the petal length as well less than 2 centimeter, you can notice that it is falling under setosa. Then you can notice for veriso color, for the verisaco color, you can notice the range lies between here and here, but the petal length is between 3 to 5. Similarly, we have the information for Virginica dots as well. So I hope this proper thing is clear to you, and we are able to infer information as well regarding each species petal length and sepal length. So I hope scatter plot is clear till now. Now the next thing we will be seeing is joint plot. Joint plot. So what is joint plot? It is also used to show the correlation between the data. So it is also used to show the correlation, it is also used to plot the correlation. Great. Now let's see what difference is between joint plot and scatter plot, because both are showing the correlation. We have also seen the difference between the KDE plot and then what we say KDE plot and distribution plot earlier. Now let's see what difference is there between joint plot and the this scatter plot. So let's first draw the joint plot. SNS dot joint plot. So as I've discussed earlier, we need both x and y axis to draw the correlation. So let's copy this thing, Control C, and let's paste this thing over here, Shift enter, and see what happens over here. Oh, joint, Shift enter. Great. Okay, let's do one more thing. Kind equal to reg, Shift enter. So here you can notice first, let me remove this one. Okay, so here you can notice that we are getting the joint plot over here. This for each this sepal length and petal length, you can notice that we are getting this kind of scatter plot, and then apart from that we are getting bar plot as well. Now we can also pass one more attribute, that is the kind. Basically the kind of plot to be plotted. You can use either scatter, you can use hist, you can use hex, kd, reg, whatever you want. Currently it's showing scatter over here. So let's copy this one. Let's paste it over here. And let's say I want to have kind equals to Mm, let's say I want to have reg only. Shift enter. So here you can notice that you are getting the reg now. Let's make it as KD and see what happens. So now you are getting KD type. You can notice now the data is coming up over here in the form of lines. If you want, you can again change it. Let's say I want to have it as scatter, shift enter. So you are getting scatter. So basically you can see what kind of joints we have, and then accordingly you can set the kind over here. Now the next thing we will be looking upon is pair plot. Seaborn basically lets us plot multiple scatter plots. It is a very good option when you want to get a quick overview of your data. So let's try to draw that pair plot. Oh, my bad again. Okay, let's draw pair pair plot, and let's mark it down. Shift enter, and here I will be writing SNS dot pair plot, and here I will be passing the data set df1. And shift enter, and it's taking time because it needs to load a number of multiple plot over here. You can notice you are getting the ID, then you are getting the sepal underscore length data, you are getting sepal width centimeter data, then you are getting petal, and you can notice you are getting I petal width per ID, then petal length centimeter in I. So here you can notice that you have a number of figures coming up over here, and in the pairs of all the continuous data and plots their correlation. It also plots the distribution data. You can notice if you wish to pair all the column, you can pass in two more parameter, that is x vars and y vars. So you can plot the pair plot like this. Now after pair plot, the next thing that we will be talking about is heat maps. Heat maps. Let's mark it down and let's draw it. So basically, I hope all of you are aware that basically it is a confusion matrix over here. It shows the correlation between the different what you can say different fields present over there in your data set. So let's try to draw the heat map over here. For the heat map, I will be writing CORR equals to df1 dot CORR bracket, and then I will be writing SNS dot heat map, and I will be passing this core inside this. Shift enter, and you can notice that we are getting the heat map over here. So you can notice that how petal width and ID is dependent on each other, and how sepal width and ID is over here. And basically we can customize the color scheme as well, the maximum and minimum value. Also you can change the color of annotation. So based on this heat map, we can conclude that this sepal width, sorry, sepal length, where is sepal length, sepal length has a high positive correlation with petal width. Where is petal width? Here. Petal width and sepal length, you can see that there is a high positive correlation between petal length and petal width. Just a second. Petal width, sepal width, great. Okay, so the as we all are aware that positive correlation is represented by darker shades and negative correlation is represented by lighter shades. So wherever you can see the darker shade, for example petal width and petal length darker shade, petal width and petal width darker shade, so basically it is a positive correlation. Petal width lighter shade, petal length lighter shade, sepal length lighter shade with this, so you can say that it has negative correlation. So you can also change the value of a knot over here, and the output will show you the values by which features are correlated to each other. So we will be doing that as well. Also, from here you can infer that for with which sepal width, we have a strong correlation between petal length and petal width, and we have negative correlation with sepal length and petal width and sepal length. So I hope this is clear to you guys. Now let's see what do we have next. We are done with heat maps, we are done with pair plots, we are done with joint plot. So we have covered almost all the graphs over here, and I hope this thing is okay. Let me do one more thing. Let me try to change the color of this and also make the not as true. Okay, let me do that. Or this thing is up to you guys. You guys need to draw this heat map with a not as true, and also you need to change the color over here of each and every this what you say this boxes over here. So I hope till now how you can visualize the data is clear, and how we have drawn the different plots over here to clear is clear to you guys. And we were able to infer a lot of information about the two data sets that we have used. The one was Titanic and the other one was Eris. I would request you guys to kindly practice this from your end in order to understand the things more. Actually, there is a number of plots present over here in this seaborn, and it is not possible to cover each and every plot in the class. So would request you guys to explore from your end as well. The more you will explore, the more information you will be getting about the coding part. Coding is something that comes by practicing. It is not like I will be helping you guys with each and every plot and it will simply get into your mind. So you need to practice for that, you need to explore for that. So kindly do that, and do let us know if you have any query regarding this. We are always there to help. Take care, stay safe. Bye bye, guys.